Well, I hope I didn't leave anything out, but for those of you who wanted to build this thing, it's kind of generally the schematic I followed. So I don't know if you can see all that well, but on this side it was my induction charger or induction pad, whatever you want to call it. So I used a 555 timer, and in was about 12 or 15 volts. I stuck a diode in there so that if I had put the wiring in wrong, it would burn the thing out. So then you can see that's a 1 going down to ground. 2 and 6 connect here through a capacitor. This capacitor actually changes the frequency, the general frequency that you can get out of this thing. That goes to ground. You can mess around with that on a breadboard until you get what you want. This is a 1K resistor and a 10K potentiometer, and then it goes to 7. Remember, this is going from 2 and 6. It's kind of bridged here. It goes up to 7, and there's another 1K resistor, another 10K potentiometer, and that goes up to the positive rail. And when you twist those, you can see on my box, this is what I was twisting, and this fine-tunes the frequency for your coil. Because a lot of people have a hard time matching coils when they want to do inductive things for transferring energy that way. In this fashion, you can just tune, your box to whatever coil you make, and you don't have to worry too much. So then it just goes through like a 100 ohm resistor to help protect the base of a NPN transistor. I used a power transistor because I wanted more power going through it. And then I just wrapped a coil, and that's on the top of the inside of the box. And I think I put a diode there to keep it from the back EMF from blowing out the transistor or the 555 timer. 555 timers I use are actually low energy. You don't even need that much, but they'll take up to that much power. So on the other side, in the actual glass jar, I basically wound another coil, and I like to use hot glue when I make my coils, because they just turn into like plastic pucks, and it's pretty nice, and they don't fall apart. So that would be this coil here, and it obviously had way many more turns. Then I played around with it, and I changed out a non-polarized capacitor in here to kind of tune it while I was turning the knobs on the potentiometer, and I ran it through a bridge rectifier, and I used my multimeter to find the sweet spot to see where it was producing the most power, the highest current. Then I ran that into a 5-volt regulator, and the 5-volt regulator is powering an Arduino that I made. And if you want to learn how to make your own Arduino, there's plenty of resources out there on the Arduino website, and it'll help you out. There's some instructables too, and they're good. That's kind of what I used. So then I used chains of LEDs, 9 of them for each color, but they're all, basically there's only 9 pins powering 18 LEDs. So basically the 2 sets of colors are run off of the same pins, and then I just used 2 of the pins, I think it was like 2 and 3, pin 2 and 3, with a 1K resistor on 2 NPN transistors. These are just small, cheap Radio Shack, like 2N22222 or variant transistors, and by switching them on or off, you can either have both sets of LED colors on, or like I did, I just had them alternate back and forth so that you could have a spiral of one color and then a spiral of the other color spinning at the different times. So it's all grounded, and I just put a false ground here so you get an idea that this is all grounded, but there's actually no wires connecting the charging mat with the Arduino beacon or strobe, whatever you want to call it, in the glass jar. There's no batteries in the glass jar. It's literally just that coil running through this bridge rectifier, basically pulling it back down to 5 volts so that it's a steady voltage for the Arduino and current, and that's about it. So if you have any questions, you can ask, and I'll try to get back to you guys.